All right, so we are going to start a new chapter today. Let's finish up chapter 1. Chapter 1 was kind of an introduction to a lot of different things. That we had, all that domain array stuff, and then basic functions, and all those different deals. What we're going to do now is take those different kinds of functions and explore them in more detail. So in this chapter, we're going to talk about polynomial, power, and rational functions. What's a polynomial, by the way? Can you give me an example of a polynomial? Gabe?
Like the powers.
Yeah, the powers. So any normal thing, y equals 3x to the 4th minus 2x cubed plus 7x squared minus 4x plus 12 is an example of a polynomial function. So we're going to start by talking about those. And we're going to start by talking about the two simplest kinds of polynomials, linear and quadratic. What's the exponent in a linear function? Nothing?
It's 1.
It's 1. It's not 0, it's 1.
It's just,
Okay? So a linear function has the highest power equals 1. And what is a quadratic function? Yeah, highest power equals 2. Okay? So we're going to start with the really, really simple ones. So let's do that right now. Ready?
No. What are the quadratic?
Okay, so like I said, we're going to start with linear functions. What is the general form of the equation for a linear function? Y equals mx plus b. So this is one of the very first ones that you learned way back in 8th or 9th grade, maybe even 7th grade. Y equals mx plus b. So we'll start with the easy stuff. Let's write an equation for the linear function. For the linear function where f of whoops, that's going to cause me problems. F of negative 1 equals 2 and f of 3 equals negative 2. Here's the translation into English of what this means. If it says, and then so now you guys talk. If it says f of negative 1 equals 2, what they're saying is that the point negative 1 comma 2 is on the line. Because this is f of x, right? So if there's a negative 1 in there, that means x equals negative 1, and what it equals is the y. So there's also the point what on the line? 3, negative 2. And so what we're being asked to do is come up with an equation for the line that goes through those 2 points. So what do we have to do first? Find the slope. And who remembers the slope formula?
Y1 minus Y2.
We usually go the other way around, but either way works. Y2 minus Y1 over X2 minus X1. Like Becca said, you can go Y1 minus Y2. As long as you also go X1 minus X2, then you'll be okay. So what's our Y2? Negative 2. Minus, what's Y1? What? 2. Sorry, I didn't hear you. What's X2?
Negative 3. Sorry.
3 minus, what's X1? Negative 1. So negative 2 minus 2 is negative 4. 3 minus the negative 1 is positive 4. So our slope is minus 1. Okay, so that's the first step. Find the slope between the 2 points. What do we do now that we know the slope?
Put that in for
Put that in for what?
M.
M, okay. So I'm going to take the general equation y equals mx plus b. I'm going to put -1 in for m. What am I going to put in for y?
Either one of the y points.
Either one of the y's. Which one do you want to use?
2.
Okay, so we're going to use this as our point. So we're going to put in 2 for y. What do I put in for x? -1. And what do I put in for b? Right, which is what we're trying to figure out right now by putting those things in. So we don't know what it is, but we're going to in a second. Okay? So that means that 2 equals -1 times -1 is 1 plus b. And if you subtract 1 from both sides, then you get b equals 1. Okay? So now we are ready to write our final answer. Y equals -1x.
Plus 1.
You could just put -x and you should plus 1. So in other words, y equals -x plus 1 is the equation for the line that goes between those 2 points. Okay? Okay. So we're going to use these linear equations to model data. And when we're modeling the data, then there's a few different ways that things can work out. You can make a scatter plot, and it could look like this. Wait a minute. Let's do it a fun way. Okay, and if your data came out like that, you would say, what kind of correlation is there? Linear. What else? Positive, y is showing up, and what else? Strong, because if I draw a oval around here, it's fairly elongated. All of the points are fairly close together, okay? Whereas if I, whoops, that's not what I want. If I took these points and spread them out a little bit, then you might say that it is still linear, but that would be a weak correlation. And then if things get super crazy and we really spread them out like this, then you would say what? There's no correlation, right? And then you can also take these and move them the other way so that they're going down instead of up. And in that case, that would be a negative, probably a strong negative correlation, okay? Or you can have a weak negative correlation. So we're going to have our calculator figure that out for us, and it does that using what's called a R variable.
Mr. Aldridge?
Yeah.
Should I go get my calculator or use one of yours?
Say that one more time.
I forgot my calculator, so should I go get it or use your one?
You can use one of mine. So the correlation coefficient, which is the letter R, tells us what type of correlation there is between the, or with the data. Yep, it's just called R. And so here's the things to know about the correlation coefficient. First of all, R is always going to be in between -1 and 1. Secondly, if R is positive, then not surprisingly, there's a positive linear correlation. Okay? And guess what? If R is negative, this is where I could use the little things, but that would be more confusing than, you know, the little But everybody freaked out last time. Then there is a negative. Linear correlation. And the closer the opposite value of R is to 1, the stronger the correlation. On page 161, there is some data. 161, weekly sales data based on marketing research. And so we're going to take that data and we're going to enter it into our calculator, and we're going to see what our calculator has to say about it. So have we done this yet this year with this class? I don't remember.
Yes.
Yeah, that's what I thought. Okay, so stat edit cleared out the junk that's there already.
It was to enter precise.
Yeah, so we'll go 2.4, 2.6, 2.8. Those are going up by 20 cents. Okay, so you get that all entered into L1 and L2. If you go to y equals and turn on one of your stat plots, and then go zoom 9, then yes, like Taylor said, you should see that you have a negative correlation there. And that makes sense, or should make sense in your head. The higher the price, the fewer boxes you're going to sell. So as the price gets bigger this way, the number of boxes you sell on this axis is actually going to go down. Okay? And this looks fairly linear. And you might actually say how strong, weak, what?
Strong.
Fairly strong. All right, so let's see what the calculator has to say about that. So now go stat, over to calc, and then number 4, linear regression, and then hit enter. Okay? And you should come up with not only an equation for the line, but also this R value right here. And if you don't have that R value, let me know and I'll tell you how to turn that on. Is there anyone who does not have that showing up?
I swear we already did this. Like,
Yeah, we did. Okay. So it's pretty close to 1, and so this is a pretty strong correlation. And you can see that if we had this entered into Y1, yeah, we did this a little bit in the last chapter. Then when I graph it, it's, I guess it doesn't, well, it goes through one of the points, but all of the points are pretty close to that line, okay? And then you could figure out, how much profit you would make and all that kind of fun stuff like that, okay? Go figuring that out. All right? Easy stuff? Okay, so let's stop there with linear functions, and tomorrow we will talk about quadratic functions. I'll give you some problems to work on right now. R value.